Good afternoon, student. So yesterday we have
Good afternoon,
started.
sir.
Good afternoon. God bless you. So yesterday we have started this storage of solids. We have completed 2 or 3 lines. I'll complete this and then go back to the next slide. Now, as I said that the storage of solids is very important in our chemical industry. We have to follow the norms and then we are supposed to design the systems according to our requirements. Now let us see bulk storage. Means what? We are supposed to store the materials in very large quantities. That is the meaning of bulk storage. Core solids, solids whose sizes are measured in terms of millimeters or in inches. That is, as soon as we get the materials from the ore, we do the primary crushing for easy in the transportation or for materials handling. So from the source of ore, we bring it to our place, and this we are supposed to store it. Coarser solids like gravel, kankara, sand, etc., and coal are stored outside in large piles. Okay, we are supposed to store them in very large piles. కుప్పలుగా పోసుకొని పెట్టుకుంటాం అన్నమాట. Unprotected from the weather, because I said that the degradation of material takes place because of environmental factors. In that, the first one will be air, then the gases which are present in the air chemically. You may be knowing that Taj Mahal is becoming brown in color because of the. Then they found that what is the reason behind it. Then there is an inquiry committee was there, and they found that it was the sulfur dioxide which is doing this problem. Sulfur dioxide is a weak acid, and marble is a basic in nature. So Mathura Oil Refinery was emitting a lot of sulfur dioxide, and this went to Taj Mahal and then started reducing its glare, కాంతి, మార్బుల్ యొక్క కాంతిని తక్కువ చేస్తుంది. Hence, then they started thinking, and then they asked the Mathura Oil Refinery to shut down the plant or reduce the sulfur dioxide content. And now a project work is also taking place for restoring the beauty of Taj Mahal. So these are some of the effects I'm telling. Gases which are present in the air, their concentration will be very less, but in prolonged use, the effective value of the material decreases. And then when hundreds or thousands of tons of materials are involved, this is the most economical method. So if you are going to store them in large quantities, constructing godowns is very difficult. So at the same time, we will use this kind of method, that is open storage in piles. The solids are removed from the pile by dragline or a tractor shovel and delivered to a conveyor or to the process. So we store them and then we are supposed to take them for the process. For example, I said the boilers, they will be storing near to the boilers, they will be storing coal in lumps, in the piles. And from there, how is going to bring it? Generally in our pharmaceutical industry, we will employ human beings. They will be breaking the coal and then they will put it in a tata, and then from there they bring it and put it in the furnace. But in case of a large thing, for example, steel industry, where heat requirements are very large, so the capacity of the boilers are very high. In that case, what to do? We are supposed to use machines. What type of machines we are going to use? I am going to show it now. So this is how we store the coal outside only, without unprotected, because the value of this coal will not change with respect to time because of the environmental factors or anything else. Nothing will happen to it. If we find that the materials which are used in our factory, they do of the same nature, then we can store them as in this kind of things. If not, what we should do? This is if not, what we should do is this one, like that. So you construct a big sheds like this, and if you find that, and there is also a reason is there. For example, you take this slide. Even if the air flows, also nothing will happen to it because the size of the particles are more. So the drag force exerted by the fluid and the solid particles is very negligible. It cannot it cannot initiate any movement in the solid particles. So hence, no problem. But if you are storing powders, then of course there is a problem will be there. In that case, because if the wind comes or then, for example, tufan or then tsunami, any such kind of things, unfortunately, if your factory is there of course you are going to construct this kind of godowns, and there inside the godowns, warehouse, you are supposed to keep it. So we are supposed to cover that entire pile by means of a temporary shed, and then we are supposed to store the materials, and then afterwards we can use it for the purpose. And this is one more method, entire covering by tarpaulin cloth. This entire dome is made up of tarpaulin cloth. This is covered with it, and then we can store the materials. So from the top we are going to dump the materials by means of conveyor totes, and from here we can take out the materials. Okay, this is how we store the materials outside if they are their quality changing with respect to environmental factors. then we follow this method. Then the solids are removed from the pile by drag line or tractor shovel and delivered to the conveyor or to the process. So this is the example of a tractor shovel. So the human will be sitting here, and then he will bring this box down, and then he will lift the particles. From there he will go to some other place where the need is there. He will put it. Okay, that is the only role of him. So this is the example of a tractor shovel. And then second one is drag line. So especially these drag lines are very important in case of iron and steel. And I'm talking about large scale industry, not small scale industry. In small scale industry, we have human beings who can do a number of jobs. And here you take the iron and steel industry, or you can take even the Gayatri sugars also. In Kamareddy, the Gayatri sugars are there. There also the pulp is transferred by means of chain conveyors. So here the coal will come and then it will fall into it. And suppose if you want to transfer it, so we will lower this ladder down and then we keep it at the bottom. And with the help of human beings, that will be dumped into this, and the conveyor belts will fall, and then from here it is transported where the requirements are there. Now they may go to the furnace, or they may go to some other place in the factory, wherever need is there. So these are all a temporary arrangement, because once we discharge the materials from this pile, now this entire setup will go to this pile, and like this we use 24 hours. We use the material transfer. And then so this is the meaning of a drag line. Okay. So the previous slide is tractor shovel, and this is the example of a drag line. Okay. Sorry. And this is the conveyor belt which are going to use it. Suppose if you take the case of coal, then of course the powders of coals are put it here, and then this machine will run. This is a helical screw conveyor. So once you put the material will be transferring the material from left hand side to right hand side. So here the length is very big. So a number of items can be added in series, and the materials will continuously transfer. So what is the difference between this transportation and this transportation? If there is a spillage problem is there, don't go for this. If the materials are denser in nature, they don't fall down. Okay, the velocity of the belt is such a manner that it cannot create any motion in the solids. Then in this case, we can go for the drag lines. Suppose if the powders are there and there is the chances of spillage or flying away, then of course we can use this kind of conveying system, where in a trough the helical screw conveyor will be rotating. We dump your materials. See, remember, dumping the materials is done by human beings only. 3 or 4 persons will be engaged in this, and they put it here, and automatically the material will be going on. And the mass carried by the human being will be very less, but of course this machine can handle that mass 24 hours anytime. Okay, so here we have a pulley, and this will be driven by means of electrical motor. So like that we can align a number of screw conveyors in series, and then we can increase the capacity of our materials handling, or we can predict the distance and then we can use this. Outdoor storage can lead to the environment. Yes, yesterday we stopped at this point. Now we'll continue from it. Outdoor storage can lead to environmental problems, such as dusting or leaching of soluble materials from the pile. So if you keep the material outside, we know why we are going to keep it. If the materials are not at all reacting with the environmental effects, the quality of the material is not changing, not affected by means of environmental factors, such as air, such as the presence of gases inside the air, such as the microbiological action, such as rain, etc., etc., then we can safely do it without any covering. But suppose if we find that there is a problem is there, then of course we can supposed to cover it, the material, by means of the tarpaulin cloth or temporary sheds we are supposed to put it, because as the wind flows, what will happen, the dust particles may come and fall onto this, because dust particles cannot be flown across the solid. So these solid particles will entrap those dust particles, and then they will become impure. So in that case, what we should do is we should cover it by means of tarpaulin cloth or constructing of temporary sheds. And apart from that, if rain is there, then there is a chance. Suppose if rain is there, what will happen if you keep a cement bag outside? The water enters the cement, and then immediately it will become solidified. So understanding the pertinent properties of the material is very important. First point. So hence, if it is soluble in the water, consuming the water, in that case, what you do? No other role. You are supposed to cover it. Whether you are going to have a 5-ton pile or 25-ton pile, you are supposed to go for a covering system for that, as we have seen in the domes. Leaching can be controlled by covering the pile or by locating it in a shallow basin with impervious floor from which the runoff may be safely taken. Impervious is what? The material which will not allow the penetration of fluid. It will not allow. That is the name of impervious floor. So when the water falls, what will happen? the material may melt, the material will be dissolved, and along with the water it comes down. So now what we should do, the material, loss of material is there. So now you collect the material safely and then take it in a carboys, and then you try to do some necessary action so that you can regain your material back. Okay, that is the meaning of it. Or else, simple thing is cover the pile. That prevents lot of difficulties for us. Yeah, no, this is the example of a bin, okay, where this is actually a concrete bin. So we store the material from the top, it falls into it, and when we want to take it, we will take it from the side. Remember, a bin will have an outlet from side only, not from the bottom. Remember this, because it is not possible for us to create a opening from the bottom, because we have to go beyond this earth level and then do some things. So in majority of the cases, the grains are stored like this, and then from the side we take out the feed, and from here it will be falling into this conveyor belt. From here we can discharge it, and then we can take to a number of places. So these two are the diagrams of the bins. So what is a bin? A bin is a provision for storing free flowing solids or any type of materials in large quantities. Okay. So this is one example of a bin. So there are three types of storage systems are there. The first one is bin, the second one is silo, the third one is hopper. Okay. As I said yesterday, a bin, it is a cylinder, but its diameter is more, its length is less. Whereas if you take silo, its length is very high, diameter is very less. Whereas the hopper will have a sloping bottom. That is the difference between all the three categories. Example of a silo. So more or less it is same, but to certain extent its diameter is less when compared to the previous one. So again here also top loading is there. From other side we take out the materials. This is example of a silo which is having perfect insulation from outside. If you see outside the steel color whichever is there, so means what we are, whenever we see steel color, that indicates that we are storing some material whose temperature should be kept low, because whenever the sunlight falls it will reflect, so that there is no penetration through the insulation. So to such an extent we can increase the resistance of the insulation. Okay, this is how we are supposed to do it for storing fluids at low temperatures. Okay, steel coverings are there. Suppose if it is heat required material, then we are supposed to put it by black color. So when you put black color, what will happen? The steam pipeline, generally after the insulation is over, we put black color over it. Why? Because it can absorb heat, and then that heat can pass through the insulation also, may pass, may not pass, that is a different story. But black color absorbs this thing, so that the losses is not there during the transportation. This is the example of silo, and this is the example of our this is the example of the hopper. Okay, so hopper is similar to that of a silo or bin, but at the bottom we will have a conical one. This is very important, because this feed will come from here, and with the help of a conveyor belt it will fall into it. So uniform falling is also very important, because if the solids are falling non-uniformly, what will happen is the stresses which are developed inside the body, they will be different, and that may lead to the failure of the metal of construction. So in order to avoid that, the central loading, central discharging is very important. So at the center of the silo only we will have an opening, and then these solids will fall here, and with the help of a conveyor belt they fall at the center, so that uniformly the growth of the pile, kuppa, will be there inside the system, so that uniformly it will be exerting pressure on the walls of the silos. Then when you want to discharge it, what will happen? You will have a conical bottom. So this is the example of a conical bottom, and here we have a feeder. Feeder means what, sir? In a controlled manner that will be giving solids to the next system. Okay, next system is what? Again here we will have a conveyor belt, and from there these solids will fall. But of course, once you open the valve, what will happen? Everything will fall at a stretch, what will happen? Then of course the conveyor belt will be overloaded, and there is a chance that the material may spill out and fall out some other place, and there will be loss of material will be there. So hence, to avoid that, we are supposed to fix the value of m dot, that is mass flow rate. So hence here we have a feeder where we have a valve which is rotating here, impeller inside which is rotating, so that it takes the material from the back, and then in a controlled manner the solids are made to fall on a conveyor belt. So from here the conveyor belt falls and goes to some other place. So if you remember our municipal water treatment method, this is one of the example where we store the alum, and the alum will be falling from the silo in a controlled manner to the belt, and belt will also rotate with uniform velocity, because the dosing is very important. So here we have sodium soda ash, and here we have the chlorine activated carbon. From there it goes to the mixing tank. So this is the basic example of a silo. Next, bin storage. So we are going to store them in enclosures. Storing in an enclosure is called as bins. Solids that are too valuable, yes, the cost is very high and we cannot take any chance them to be exposed to the atmosphere and degrade the quality of the product. So those kind of materials, too valuable, are too soluble to expose in outdoors. So if they are having a property of dissolving in rainwater or etc., then of course we are supposed to take proper care. Too soluble to expose in outdoor piles are stored in bins, hoppers and silos. In these three categories, we are supposed to store them. In generally, design characters is what? If nearby area, we don't have much problem of what you say is winds, because we are constructing some things which is going into the sky, isn't it? The silo or the bin, whatever it is. So if the air moves very fast, what happens? There is a chance of twisting moment will be there. So in such kind of areas, we'll go for the bins. And whenever we want to ensure a supply from the side, so we can go for the bins. If this is not a problem, then we'll go for the silo. Whether you go for bin or a silo, you keep a hopper at the bottom. That is very important. These are cylindrical or rectangular vessels of concrete or metal. Most of the cases, they will be, in case of rice mills, etc., they will be concrete. Or else we can keep metals also, because the cost of the metal is more than that of the concrete. So what does the material suits is important. So hence I repeatedly say the pertinent properties of the material is and its reactivity to the metals is also important. So based on that we are supposed to select it. And suppose if you are storing methanol, we can't use a concrete structure, because when you are storing methanol in large quantities, insulation is a problem, because at the same time the second one is what? Heat transfer, because the temperature in the summer, the temperature rises to 45-50 degrees centigrade. So the metal, since the tank is exposed to atmosphere, there is a chance that there will be breathing losses will be there. In that case, we cannot even imagine a concrete thing. We are supposed to go for metals which are having external jackets, or internally we can use lumped coils of heat exchangers to reduce the temperatures of methanol so that the breathing losses are less. Yeah, a silo is a tall and relatively small in diameter. A bin is not so tall and usually fairly wide. So as I said just now, silo's diameter is less, length is more. Bin diameter is more, length is less. But the hopper, it should be present at the bottom for ensuring continuous flow from the system. A hopper is a small vessel with a sloping bottom for temporary storage before feeding solids to a process, only to ensure continuous supply without any arching. We'll see a disadvantage called as arching, and then without any disadvantage, we can feed the materials to the next processing equipment via hopper. All these containers are loaded from the top of this some kind of elevator. So how we are going to do this is important. How we are going to load them here, if you see, we have a conveyor. So up to here, the materials are lifted by means of bucket elevators, and then we put the material and then we charge it, because you know the sizes of these are very big. So we cannot expect human beings to take the material to the top and then put it. So we use bucket elevators, and then we charge the material, and then from there it falls, and this falls into the belt conveyor. So thereby the loading will be taking place. All these containers are loaded from the top by some kind of elevators. Discharging is ordinarily done from the bottom, as I have shown you. As discussed later, a major problem in the bin design is to provide satisfactory discharge. So whether you store the material in a bin, whether you store the material in a silo, ultimately our concept is one: we should be able to give the solids, issue the solids to other process continuously without any problem. That is important. If not, your design is wrong. So to avoid that, in majority of the cases, we will be using silos, and especially hoppers. So especially when you are using bin or the silos outside, better to keep a hopper assembly at the bottom, so that continuous supply will be there, and then with the help of a drag line, you know what is the drag line, we can take out the materials. So this is very important. Next. Now let us see what are the difficulties which we are going to face when we wanted to store the solids in the bins or in case of the silos. Let us take the first example. I am keeping a small spherical ball which is having considerable amount of mass, and it is having a density rho p, and it has a diameter, so hence it has a volume. So once I keep it here inside this box, what will happen? Because of the existence of the mass, this will be experiencing gravitational force in the downward direction. So here I represented it. So when because of this weight, this mass, what will happen? This object will be exerting some force on the floor. And in our fluid mechanics, we term this as base pressure. But the base pressure for in case of the solids, in case of the liquids or discontinuous solids is totally different. That is another argument given by Jensen's equation. So once I keep an object here, what will happen? The object will be exerting some force on this plate, and let us say, for example, that is P. Now the point is, how do we calculate P? That is very important, because P is given by the formula force by area. Force is equal to what? Mass mg by gc. You know m, mass of the object. G you know, gc you know. mg by gc gives the value of mass. So you know mass. So pressure is equal to force per area. So from mass you calculate the force. And force divided by the area. Which area you are going to divide? That is the contact area. That is very important, because the entire surface is not exposed to this plane. Only some part of it is exposed. So now you take the tip of it and then think that is a circle. And then the circle's diameter, that is pi by 4 d square, will give the area. So force by area gives the pressure exerted. And you find that in this case, in this particular case, denominator area is very small and automatically numerator is more. So hence the force exerted by this object on this plane will be very high. That is what I want to conclude. Then what you do is you take this same mass, same material, rho p is same. But what you do now is you try to take a cube. So when you try the cube, what will happen? The area will increase. So mg by gc is same, no problem. Numerator is same. But what will happen to the area? The contact area is increasing now in the second case. So hence, when the denominator is increasing, what will happen to the fraction? The fraction decreases. So hence, the pressure exerted by the cube on the plane surface will also decrease. So this is how we are supposed to think it and then design the systems. Means what? We should have a proper knowledge that what types of solids we are going to use, because in that particular design we should not allow other materials to come and sit in this place, because the design process will be changing. So hence first you try to understand what is the nature of the material, whether they are sticking to each other, whether they are free flowing. The second one is what is the density of it, and the third one is what is whether the particles are regular shapes or irregular shapes. Irregular particles are those particles whose shapes are clearly defined, and regular particles are those whose shapes are clearly defined, and irregular particles are those particles whose shapes are not clearly defined. So you are supposed to see what category you are going to what category you are going to use for your storage, and based on that you are supposed to design. Now this is the story with one spherical ball. Now second one is, and if you see here, one more thing, I'll introduce a term called lateral pressure. What is the meaning of lateral pressure? The pressure exerted by this spherical ball in the sideways from its peripheral surface area is called a lateral pressure. That is also very important, because as the time passes, as you start loading the solids, even the lateral forces will also act by the solid on the object. So this also we are supposed to consider it. So then only we can think what is the strength of the base, strength of the material which you are going to use for the base, and what is the strength of the material which is used for the sides. Because the base should have good strength. So if you increase this, if you keep the same 12 mm thickness pipe to metal pipe to this, what will happen? The cost will increase, and then entire this one will be putting the weight on the base. So hence, what is the foundation cost? This will be very high. The foundation cost is also very high. So hence, to avoid this kind of anomalies, first try to understand what is the base pressure and try to calculate what is lateral pressure. Based on that, you can increase the thickness and decrease the thickness, so that your overall cost of the equipment will be decreased. That is the main objective of it, without undergoing any problems. Problems is what? It should not collapse by taking the quantity of the materials. And generally by filling, we will take 100% filling. Means what? The entire box is completely filled with the solid particles. This is what we are supposed to assume it. Then now suppose when you take the second box. In the second box, what did I do? I kept the second particle. So when I kept the second particle, what will happen? Yeah, the force, mg, P, base pressure, two are there now. But now because of the presence of this, what is happening is, because this one especially, this is under the tension or the compression by this one, and then since it cannot move this plate, even the plate will also have the negative force exerted on it. So here there is no concept of lateral pressure. And here in this object, we will have a lateral pressure. And moreover, this one, if you see, according to Newton's third law, whatever the lateral pressure is exerted on this, that will be applied by this. So here there is nothing is there, here it is there. So you can imagine what will happen to it. Okay. So now if you increase one more thing, what will happen? 1, 2, 3, 4. All the 4 are there, perfectly accommodated. And remember, they are in a line. And now what will happen? This I call it as 1, 2, 3, 4. 1 will have base pressure, will also have lateral pressure. And this lateral pressure, what will happen? This will be exerted by this plate on the, this solid on the wall of the bin. Whereas the second one, if you take it, it will be exerting the force on the base, but it will have lateral pressure exerted on the particle 1 and particle 3. It will try to push it. And similarly, the story continues for this. Now, suppose, imagine the situation is there like this. And now, based on this, we put some other particles over it. So now we know gravitational force is acting in the downward direction. The linear pressure is acting in the downward direction. But the lateral pressure will be acting in the sideways directions. And remember, if this is the story when the objects are filled horizontally. But suppose in a bulk of solids, there will be different types of angles also. So the entire surface area of the object exclusively down, other areas we will have the angular forces only, which may be termed as lateral forces. So now, as you try to put more amount of the solids, the lateral forces will be building, and similarly, these lateral forces will be exerting some force even on these two sides also. That is important. Whereas in case of the liquid, it is a uniformity can be maintained because of the concept of continuity. Whereas in case of bulk solids, because they are not continuous solids, the problem is vigor here. It's very high. That's the meaning of it. So now what I will do, I will take the same box and then now I start filling it. So during the filling, I can do random packing or regular packing. What is the meaning of random packing? We will fill it once and then we will forget about it. But what is regular packing? After adding every particle, we give with the help of vibrators, we shake the equipment so that it occupies the appropriate place and the porous value, air fractions will be very less. So that our aim is to accommodate more an amount of the solids in the given network. So that kind of packing will be termed as a regular packing. Then, as I try to add the particles, but in my subject there is no concept of regular packing or irregular packing. We simply dump the solids from the top, and then once the content is full, we open it and then take it out. Okay. Now suppose you go to the second one, the layer is increasing, fourth one, fifth one. Now suppose you come back to this slide. Now how many layers are there on this particular one? More amount of the layers are there. And already all in this, if you see, all the material solids are under the force, application of forces, because this is pushing this one, this is also pushing this one. So this is also pushing. So like this, because of it, all are in contact and they are in tension also. So now suppose if the tension is very high, now tension will be very high when you try to draw more amount of solid particles. Now this particle will also exert some weight on this. This will exert. So the entire weight of these solids will be felt on this particular line. Unfortunately, this line is falling in straight. So the line of application of orientation is also very important. Why I am saying is that in your house also you might have experienced when you have a granular solids and closed packing is done. Generally what mothers will do, they will shake that container and they will try to accommodate more. And suppose if you don't take it after certain time, once you take it, tilt it, the solids will not fall because of arching. This is the problem. So because of arching, the solids will not fall. Now in that case what we can do, with the help of a spoon or anything else, if you scratch there here and make it a free flowing, once you tilt it, then again we can generate the flows. So arching is a disadvantageous thing in case of storage of solids. That is very important. So we should see that arching is not formed. Now the point is from where the arching is gone, that is important. So here we have the term called as friction. So these materials, if they are exerting here, and if they are intention means what, they are expressing some amount of friction here. The friction here, for this one, if you see, it is the friction between the parent material and material of construction. Two different things are there. But here, if you see all these things, it is because of the internal friction of the materials only. So if the friction is very high, and the second point is that here we are having regular faces. Suppose if you have irregular faces, what are irregular faces? Shapes which are intricate, which are having sharp corners. Then in that case, the pronunciation of friction is very high. So in that case, it is very difficult for us to generate the flow only. So how to break this arching is very important. So now you try to fill it. So now all the solids will be exerting this weight on it, and this will be under high tension. And sometimes what will happen when you open this entire basin, entire plane, the solids are having enough tensile tension. They are in a tension such that they can lift the entire solids on the surface. So once you take it out, what will happen? The materials will not fall. So in that case, what you do is you just poke it something here or give some vibration to the disc. So this internal friction will decrease and the tension will decrease and they collapse suddenly as all solids are falling down. So this is called as arching, and this is a disadvantageous thing for us in case of generation of flow, in case of storage of bulk solids. But if you see some tunnels, okay, suppose if you see old buildings also, so there we have an arching like this. So we have a brickwork arching like this, and we have a big wall. So wall will not collapse. But suppose if you have a plain wall like this, then of course we are supposed to keep a platform here, concrete platform. Based on that, we are supposed to construct this brickwork. These are called as, I think, Sadzaru in our Telangana. When we construct the work, they will be, especially Almaras, they will see it. Because in Almara, we have a window, isn't it? So there is no mass is present. But the brickwork will fall down. So to avoid that, they will put a concrete slab here. And that on the top of it, they will be putting the brickwork. But in the olden days, if you see, there will be only arching will be there. So what is significance of arch, sir? This arch will support the entire solids which are there on the top of it. So this is very important concept there, but arching is a very bad thing for our subject. So once, as I said, that you remove the base or you open the start the flow at the bottom by opening the bottom wall or the feeder, then we can certain extent generate the flow. Then afterwards suddenly it will stop. It will stop because of the line formation. All the solids are in tension, and their friction is very high, internal friction is very high, such that they are able to support the weight of entire solids which are there on the top. So it is this layer which is the culprit. Okay. So now if any attempt is there to break the friction, so how to break the friction? Use some vibrations to this metal, or you poke it suddenly with the help of a rod. All these particles tension will decrease and they are suddenly fall on the base, and we can again generate the flow. So this is the arching, which is, so in case of a solids free flow, n number of archings will be formed and they will be broken continuously. The best way to prevent arching is what? You try to have vibrators to this device, so that these vibrations will break up the bridges or friendship between the solid particles by means of friction, and then the free flow will be ensured. That is the meaning of the sentence. Yeah. Yeah, this we are seeing. Pressures in bins and silos. When granular solids are placed in a bin or a silo, the lateral pressure exerted on the wall. So now remember, the tension between the layers of the solids is only because of lateral pressure. So if you see in some of the movies, suppose the hero will be standing in between two trees and then he do some yoga or karate, isn't it? How it is possible, sir? Yes, it is possible because he is pushing his legs on the trees, applying more amount of lateral pressure, and thus he will support his body to it. Okay, and even in the gymnastics also you can see some kind of, especially in Telugu movies you see that the hero stands in between two tari chetlu and do some circus. Okay, it is one example. Sorry for quoting this example. Then, so it is because of the lateral pressure. So if the lateral pressure is very high, then definitely the arching formation is must. When granular solids are placed in a bin or a silo, the lateral pressure, what is lateral pressure? The pressure exerted by the solid on the sideways, not on the base. Base is what? Linear pressure. And the ratio of lateral pressure to linear pressure is called as Poisson's ratio in strength of materials. And this Poisson's ratio is very important for us to understand it and to design the storage bin for the solids. Once again, the ratio of lateral pressure to linear pressure is called as Poisson's ratio, capital K dash. Okay, this may be a bit question for you. Okay, lateral ratio of lateral force to linear force, or lateral pressure to linear pressure, is called as Poisson's ratio. You can see net also nowadays it is available. Okay, and this value is very important for us. The lateral pressure exerted on the walls at any point is less than predicted from the head of the materials above the above point, because of the formation of the arch. For example, take this one. So here, if you see, the lateral pressure exerted by this one and by this one is very high. But suppose if you take this one, may not be there. If it is there, what will happen? Even this will also fall an arch. And then what it will do? It will support this entire materials. So it all depends upon the orientation of the solid particles, their intricate shapes and the friction between them, so that they can exert some lateral pressure, and if it is very high, then of course automatically arch will form. Furthermore, there usually is a friction between the wall and the solid grains. So as you know, there will be two types of friction will be there between two foreign bodies and inside the materials. So two solid particles will have some types of friction exhibited between them, but if you take the material of construction, especially sharp corners will exhibit high friction. So if the sharp cornered materials are the sides, then of course the friction will be very high and it can support the entire solid particles. Furthermore, there usually is friction between the wall and the solid grains, and because of the interlocking of the particle, what is the meaning of interlocking? That is these solid particles are interlocked. Why? Because there is a tension there between them, and because of the friction they are not able to create any movement, and they are firm in such a manner that they can support the weight on their shoulders or on the surface, we can say. Furthermore, there is usually is a friction between the wall and the solid grains. Because of the interlocking of the particles, the effect of friction is felt throughout the mass, and the frictional forces at the frictional force at the wall tends to offset the weight of the solids. So frictional forces able to withstand the weight of the objects, and then because of this, even if the bottom wall is open is there, that interlocked solid particles will support the entire weight which is there on their top, and there is no movement is there. So you open the bottom wall, no solids are coming out. The frictional force at the wall tends to offset the weight of the solid and reduces the pressure exerted by the mass on the floor of the container. So in that case, what will happen, sir? Here do you have any forces, any pressures are exerted? Nothing, zero. But here this is exerted because of the lateral pressure. These sides are exerted some amount of the pressure. So now, because of uneven distribution of forces, the pressures inside the material of construction will change, and this may lead to the fracture or failure of the material. So hence, we are supposed to see that when we load the particles, arching will not take place. Arching will not take place only because of keeping vibrators inside the system. That we'll see in the later stage. Yeah. The vertical pressure the vertical pressure on the vessel floor or the packing support is much smaller than exerted by the column of liquid of same density and height. Dear children, remember, we are talking about discontinuous solids which are irregular in shape. So there is a chances of forming this kind of line, but in case of a water, it will simply fill the container right from the bottom, and once you open the bottom wall, the liquid will continuously come out from the system without any hesitation. So there is no question of arching in this case, and the base pressure is the highest important thing here, because the base pressure is very high in case of a storage of liquids. But here we don't know. If the arching is not there, base pressure is very high. If arching is there, lateral pressure is very high. So we should prepare for both the things and design the system accordingly, so that the material will not, the system will not fail when we are dealing with storage of solids. The vertical pressure on the vessel floor. What is vertical pressure? This is the vertical pressure. This is the vertical pressure. This is the horizontal pressure. The vertical pressure on the vessel floor or the packing support is much smaller than the exerted by the liquid column of the same density and then height. So for example, you take this height, this diameter, think that the solids are not there, water is present. So here the base pressure is more, but in this case of the solids, we don't know. If arching is not there, base pressure is more. If arching is there, base pressure is less. That is what we have to conclude. The vertical pressure on the vessel floor or the packing support is much smaller than exerted by the liquid column of same density, and think that it is of same density, same height, then of course liquid will exert more amount of the pressure when compared to solids. The actual pressures from the solids depends on the value of K dash for the solids. What is K dash? That is Poisson's ratio of lateral pressure to linear pressure. The coefficient of friction, not only this, the coefficient of friction between the particles. And remember, if particle is smooth, the concept of friction will be less. But never we have a smooth particles. We have only regular particles. Because of this, in the first statement, he used the word gravel and coal. He didn't use any uniform size particles like cement or whatever it. So, for irregular particles, the shapes which are very difficult to specify, the pronunciation of friction is very high, or the value of friction is very high. And the friction coefficient, the coefficient of friction between the solids and then the vessel wall. And the way solids are placed in the vessel is also very important. As I said that in our subject we are least bothered, but in mass transfer during the packing of a distillation column or absorption column, we should go for regular packing. So what is regular packing? We should put the material, we should shake the content so that the solid particles will take most appropriate places and wide fractions are less. When the wide fractions are there, we can create more amounts of channels. When we create more amount of channels, there is a chances for more amount of mass transfer. But here, if you try to create those kind of regular packing, we can accommodate more amount of the solids. But when you accommodate more amount of the solids, there is a chance that after certain amount of time, because of the exertion of weight on the solid particles or layers of solid particles, interlocking will be there. So we generally what we do, we try to put the material from the top at the center as I have shown in this diagram. So if you see here, the conveyor belt, the material will fall and slowly the particles will be falling and kuppa or a pile will be formed here and the height of the pile will be increasing up to this level. And once it comes to this place, what will happen? Now it is the role of the solid particles to push, exert some force on the pile, and thus the pile will expand in the sideways manner. Then we can accommodate more solids. And remember, this need not have any amount of vibrators because of this hopper assembly. That is the advantage of keeping hopper assembly. But suppose if you are using this for storing cohesive solids, then the total dynamics will change. Yeah. In general, when the height of the solids columns is greater than about 3 times diameter of the container, additional solids have no effect on the pressure at the base. This is what a beautiful statement. So already he gave us a situation at what particular point the problem of arching will be there. He said one statement. In general, when the height of the solids column, height of the solids, how you are filling 1 meter, 2 meter, 3 meter, 4 meter, height of the solids column is greater than about 3 times the diameter of the container. Because of this only I told you, remember, a bin will have a side opening. A bin will have, please remember, a bin will have a side opening compulsorily. So once the height is more than 3 times of the diameter, then of course what will happen? Then what will happen? The solids, the additional solids which you put after this, they will not have any effect on it. Means what? Yes, definitely the concept of arching will be there in this. And there will be interlocking will be there, and because of the friction between the solid particle and the container, there will be a line will be there which will be lifting all the solid particles. Then the total mass of course increases if more solids are added, but additional mass is carried by the walls and the foundation, not by the floor of the vessel. Because as you try to see the beautiful statement he said, once again I read it. The total mass, of course, increases if more solids are added. Very good. We know very well. When you add more solids, mass will increase. When the mass increases, there will be some pressure exerted by the solids on the vessel. But which plane? That is important. He said, but additional mass is carried by the walls in terms of lateral pressure and foundation. Till now, we didn't talk about foundation. Foundation, not the floor of the vessel. See, sir, this is the reason why I took first example. Here there is no lateral pressure is there, only base pressure is there. The entire solid will be exerting force only on the plane. And you take here the foundation. The foundation will be supporting how many items? This base plate, this cylindrical part, this top plate, and then the object. But on the vice versa, if you see this one, when you go to the next one, here arching is found, what will happen? Yes, the base plate will be there, but the pressure exerted by that will be less. So these sharp cylinders will have sharp corners, isn't it? They will be exerting some force on it. Suppose you take a pipeline and press it on the ground, you see a circle after, isn't it? So means what? Exertion of force on the foundation will be variation will be there. So your foundation should be in a position to resist such kind of things also. Okay. The total mass of course increases if the solids are added, but the additional mass is carried if the walls and the foundation, not by the floor of the vessel, because already what has happened? all the solid particles. What here in this case, if you see it, so there is a lateral pressure is there. So this plate, this cylinder, and then this base will be exerting the force on the foundation. But since because of the lateral force what will happen, this will be exerting more amount of the force on the foundation. So hence here also that the material should, the foundation should withstand this kind of actions. But what is force exerted by this base plate? Nothing. Only the weight of the plate will be exerting on the foundation. So the foundation should withstand this kind of fluctuations. So if you see it your MBO lab, we have taken a special care for the foundation, because when you keep a machine, what will happen? The foundation, if it is not proper, the vibrations will be felt on the wall, and then you have a lot of nonsense within that wall. So once you enter the MBO lab, you see that all the machines are erected on a particular concrete foundations which can withstand the vibrations and uneven loads of the machines, and nothing will happen to the ground or the room will not be spoiled. Yeah. Next, in granular solids, a high pressure does not always increase the tendency of material to flow as that in case of the liquid. Remember, materials will always flow from high pressure to low pressure. This is because of the concept. But in case of the liquid, it is true, because in your syntax tank, when the tank is full, when you open the valve, fully open the valve, what will happen? Velocity will be at its peak, because the height is very high. Means what? The pressure exerted by the liquid on the base is very high. So hence, when you have an outlet, the liquid will come with a high velocity. But as the height is decreasing, the mass is decreasing, the pressure exerted by the liquid will also decrease, and else afterwards certain time what will happen? The velocity of the water flow will slowly decrease. This we might have seen so many times, but dear children, this is not true for our subject, where we are storing free flowing solids or coarse solid particles. So hence he has written, in granular solids, a high pressure does not initially is there, because initially during dumping we don't know whether the bridges are arching is forming or not. So initially the pressure is there, but after the bridge has formed, after arching is formed during the filling, we don't know where it forms, which layer it will form. Once it is formed, now additional weight, additional dumpage of the solid particles does not have any effect on the base plate. That's the meaning of it. Whereas in case of the liquids, no sir. As you are filling the syntax tank, initially 10 liters, 20 liters, 30 liters, 40, 50 liters, and 1500 liters, then of course the pressure will be continuously increasing. So he has written, in granular solids, a high pressure does not always increase the tendency of material to flow. Very good. Because of the pressure only, the liquid is moving with a high velocity. So this is called as head. Because of the high head, the liquid will be moving. But in the case of solids, no. Instead of increasing, the pressure often packs the grains more tightly together and makes the flow more difficult. This is the reason why the formation of arcs will be there. Already two culprits are there in the solids. Who are those two culprits? First one is their irregular shape. The second one is friction, and the friction between two solid particles, irregular particles. And the third one is what? The friction between the surface area of the irregular solid particle and the material of construction. So because of this many difficulties, definitely the arching will be forming in that. In extreme cases, the combination of gravitational frictional forces at some point, even container, causes solids to arch or bridge. So that they do not fall even when the material below them is removed, because the lateral pressure exerted by the solids is very high, such that they have formed a line and they can lift all the solid particles, and because of it, the material below it also is going out, but it will not create any flow in that composite structure where arching has taken place. Nearly all large beams contains an arch breaker. What is the meaning of arch breaker? I said they are the vibrators, or in some cases will have a special designs inside the bin. I will show you that also. These special designs, they will prevent the formation of arches. They will prevent the formation of the arches. So hence, conclusion is what? Every large storage vessel, when we are going to store free flowing solids, it should have an arch breaker. What is an arch breaker? It is a vibrator, or we should have a specific instruments, specific shapes introduced into the system to avoid the arching. That is important. I will show you that. An upward pointing shallow metal cone set near the bottom keep the solids at the discharge opening from becoming tightly packed. So this is one. So you do one thing. You open the bottom valve and then insert a cone, insert a cone into the system, so that the cone will try to allow the solids to go in a continuous manner, and it will not see that the packing, close packing is not there, the opening, because once you open the valve, what will happen? All the solid particles will try to come down. So there will be again a problem of coming together. When they come together, there is a problem of friction. This is what we are supposed to do. You see that this will not happen. So how it is not? I said that just take something and poke, isn't it? So that from there only we have drawn the technology. So in the house also, if the borehole is not coming, what we do? We invert it, put a knife and then scratch it here and there. We break the arch and then again it will form. Like that here also in the industry, what we do is you keep an inverted cone specimen, and that will, what it will do? It will see that there is no closed packing is there during the discharge. During the discharge, slowly the particles will go from the system. That is the meaning of it. This will also I will show you. Don't worry. Yeah, granular solids, especially with angular particles, must be loose in order to flow. So when we have a problem of irregular particles which are having sharp edges, we face a lot of difficulties, and then the flow, creation of flow itself will be a difficult, which we are supposed to generate the flow. Now these are the flow patterns. So when we have the concepts of bin flow or Hopper flow or Seiler flow, what type of flow patterns are there? That is very important. In the first unit, we have seen flow patterns of three natures: radial currents, longitudinal currents, and axial currents. And then we expand the theory on it. But here, what will happen is, say for example, first one. Remember, mass flow is the best one. Funnel flow is a bad thing. How does this happen? Is this is happening because of the shallow cone motive. Suppose, for example, the angle between these two is, for example, this is 90, so this is more than 90. You take it as 120 degrees. This angle is roughly 120, definitely 120. So suppose if it is reducing to 90, what will happen? Here we have a plane like this. Then what will happen? All the solid particles will sit on this plane. Perfectly they will sit. Once you open the bottom wall, only the particles which are present above, they try to come out. And then there is a gap is there which is rising from the bottom, which goes top as the solids are coming down. So what will happen? Now once this rises to the top, and then from the surface, the solid particles will be rolling down. Okay, slowly they will roll down, come down. So reverse thing is happening. What we want all the solids which are present here, they should come first. But what is happening here? The solids which are at the top, they are coming down, no problem. So they will try to come down, and then this mountain whichever is there, its height will be decreasing. But what will happen to the fate of particles which are present here? No, they will not come down. So hence this angle is very important. So this angle has brought the concept of hoppers. So I said one thing, every bin or a silo, you should have a sloping bottom. That is very important. And as this angle is more, then we don't have any problem of holding the materials inside the system. Once you open the valve, free flowing can be ensured. So this is called as, in some textbooks it is called as tunnel flow, in some textbooks it is called as funnel flow. No problem, both are same. So this is a very bad thing for us, because we are not ensuring this always. I don't know when they will come down. But in case of a mass flow, once you open the bottom wall, what will happen? The layer of the solids uniformly come down from the bottom. Like this, they will come down, and from the bottom they goes out. So a good system should ensure itself to have a mass flow. So in the flow patterns, funnel flow or a tunnel flow, both are same. McCabe-Smith says tunnel flow, and I think Richard and Carlson will say funnel flow, no problem. Okay, so this will be having, this is a disadvantageous thing, a very bad thing in case of the flow of the material. So mass flow is a good one, and funnel flow is a bad thing. Now let us see next one. Yeah, so when we have opened the wall here, so this is the example of a tunnel flow, okay, and this is the arching, because this line friction has increased in such a manner, the lateral pressure increases in such a manner, because see, these solids which are there, they are exerting the force on these particles, so sideways it will go, so they will be able to lift. So once you open the bottom wall, some solids will come down, and this gap will be there as it is. So to break this, we should have arch breakers. Okay, what are arch breakers? From the bottom, we insert a cone so that slowly the particles will be moving from the sides, and there is no close packing will be there. There is no chance of close packing will be there at the discharge. That is first one. Second one is this, continuously vibrate this solid particle so that you break the friendship or the interlocking is broken, and then we ensure that free flowing is there. Then here, of course, once you open the valve, if there is no arching is present, then the dish is, the angle is more, what will happen? The solids will be falling as a mass flow. Okay, so this is the inception or starting point when we have opened the valve, and he has explained that two disadvantage things will be happening. This is called as tunnel flow, this is called as the arching. Again, funnel flow. So once you open this, the material comes out like this, and from the top it will pull. And this is an example of a, as time passes, the funnel flow will become like this, because as the solids are moving, what will happen? The area of the funnel will increase. This is how the name funnel has come into the picture. This is one more example, illustration of arching. So once we take it out, see the angle is less here. So when it is less, what will happen? It is able to hold this. All the solids will be supported by this. So any time, any moment of time, this mass will be accumulated inside the system. So unless and until we put second mass into this, close the bottom wall and then put another mass, this will not come. But suppose if arching is not there, then of course again they will come down. But this angle is very important. Now, how to convert a system free from, how to design a system that it will not have the funnel flow, it will be having only mass flow, irrespective of the materials, irrespective of their sizes, irrespective of their shapes, irrespective of this friction. What you do is simple logic, you increase this angle. So I said this, if you draw it is 120, you make it as 145. Okay, so then this will be having a shallow angle, and then the other solids will be falling from the bottom, no problem. So how to increase this angle? With a small diagram, I have explained it here. So this is the line, and as I try to increase this length from here, you try to drag this line. So when you try to drag this line, what will happen? This angle will be increasing. Remember this. Think that you catch this point and then you drag it down. So what will happen? This line will be moving like this. So hence the angle increases. When the angle increases, what is happening? We are going from funnel flow to mass flow. So when we go in this direction, what is happening? There is no concept of mass flow. There will be only concept of, there is no concept of funnel flow. There is only concept of mass flow. But suppose if you go from this line, if you go in the reverse direction, when you try to push it inside, what will happen? This plate, this line will go like this. When it goes like this, angle is decreasing. When the angle is decreasing, what will happen? The concept of storing the solid, the concept of storing the solid particle will be increased. Okay, sir. So with this slide, I will stop it. These notes is there already in the MS streams, so I need to go through it. There, only 12 noble souls are there today. Very good. God bless them.